My name is Aidan Gurkis, and I am the Harness and Data Acquisition Project Lead on McGill Formula Electric. My responsibilities include the design and manufacturing of our wiring harness, as well as the design and preparation of our data acquisition system. Our team has been building fully electric vehicles since 2014, and last year we placed first overall at FSAE Electric, as well as placing first in design and setting a new acceleration record at 3.687 seconds at the same event. We started a design process by first considering the requirements our harness and data acquisition systems need to meet. These include requirements set by the SAE rulebook, as well as the requirements determined by our team, such as powering specific components, setting specific signals, and measuring certain physical quantities. After the requirements have been determined, we move on to our design phase. We start by taking our compiled lists of required signals and components and making a wiring diagram. This is the stage where VeSys harness design is the most useful to our team. After a wiring diagram has been completed, often after several iterations, we start to route the wires in the CAD of our car. This is done using Siemens NX in the electrical routing feature. After our CAD is completed, we generate 1-to-1 scale form boards from Siemens NX and move on to manufacturing. In the past, our team has used Microsoft Visio in our design process to create wiring diagrams. We chose Visio for this part of the design process because it was available for free through our school and allowed us to easily make large block diagrams of our harness. For our 3D design, we used Siemens NX for easy integration with our mechanical subsystems. The electrical routing utility in Siemens NX is very intuitive, which makes it easy for us to teach new members the design process and allows for a fast 3D design process. The 3D design step is very important as it allows us to ensure our wires are long enough and the path they follow does not interfere with other components while maintaining the shortest length possible in order to reduce weight. Incorporating our CAD model in our design process also allows our chassis and powertrain teams to locate cutouts for connectors very easily. This year's design, we decided to move away from using Visio because it was not purpose-built for creating wiring diagrams, and this resulted in a slow workflow that lengthened the design process unnecessarily. Visio lacked support for the addition of specific devices and connectors, which made it difficult to create connections and edit wires. It also did not have a tool to allow for quick and easy viewing or editing of connector pin lists and connections. For these reasons, we decided to switch to VeSys as the main tool for developing our wiring diagram for MFE21. However, we still use Siemens NX for a 3D design for the same reasons we've used it in the past.
Here you can see some examples of where VeSys improves on Visio's features. In this picture you can see 4 breakouts for fans in our wiring diagram in Visio. In the next picture you can see the same 4 breakouts, but now it is much clearer that they are breakouts. In this picture you can see our T-cells and shutdown buttons in our Visio diagram, and the next picture shows the same 2 T-cells and buttons in our VeSys diagram, where it is much clearer that these components are lights and switches. These last 2 pictures show the difference between one connector in Visio and the same connector in VeSys. The VeSys connector is much less cluttered than the Visio connector and has a more professional look. These are just a few features that showcase how VeSys helps improve our wiring diagram and showcases why we chose to use it over Visio this year.
VeSys was a tool that was entirely new to our team this year, and as such we had no good training resources prepared. To teach myself VeSys, I used the online training library that was offered by Mentor Graphics. This library provided a collection of video tutorials, online lab sessions, and assessments that were incredibly useful in the process of learning the software for the first time. The virtual lab sessions allowed me to learn the software before our faculty IT department had installed it on our computers, allowing me to be prepared to begin our design process before we even received the software. As we move forward with using VeSys, our team plans on creating our own tutorial documents for the software that will focus on the features that we use the most. This, along with having monitored tutorial and work sessions, will allow us to train new members more efficiently than we could if we used the provided training library. One design goal that VeSys helped us achieve was our goal of reducing the length of our design and manufacturing process. By using a purpose-built harness designer, we were able to more efficiently create our wiring diagram. This saved us valuable time in our design process. The tools that VeSys offers, such as viewing and editing pin lists on connectors, made any changes we made in our iterative design process easier to add to our diagram, which saved us lots of time. Finally, these tools made it easier to perform checks for errors in our 3D routed CAD, which saved us time in our design process and also saved us the hassle of adding wires to our harness during the manufacturing phase. We estimate that all these reductions add up to around 3 or 4 hours of saved time across design and manufacturing. VeSys also helped us to achieve our design goal of reducing the number of errors in our harness. Using the pin list tool, we were able to easily check and ensure that we had added all the necessary wires and none were accidentally left out of a sub-harness. The same pin list tool allowed to easily check for wires that were left out of our 3D design, ensuring that none were forgotten in the manufacturing process. These tools resulted in us finding less than 10 wires missing in our 3D CAD, and no wires missing in the manufacturing process of our harness. VeSys helped us to increase the professionalism of our harness design. The wiring diagrams we created with VeSys look more professional than those created with Visio. This is beneficial to improving our image at design competition, as well as when contacting potential sponsors. The increased professionalism of these diagrams also made it easier to communicate with members of our team during our design and manufacturing processes, which aided in reducing errors and reducing design and manufacturing time. The ability to create devices and add connectors in line also helped to increase the professional look of our wiring diagram and make communication about the details of our design simpler. Moving forward, we plan on taking steps to further integrate VeSys into our design process. In the future, we hope to also use the harness design feature available with the software, as this year we had only used the wiring schematic system. We feel that this feature will allow us to further streamline our design process, making it easier to understand the various parts of our harness. We also hope to integrate our VeSys harness design with our MCAD software, allowing for an easy transition from wiring diagram to routed harness. This would greatly reduce the time it takes us to design our harness, while also eliminating the potential for errors that arises with manually entering connections in MX. We hope that we can continue to use VeSys and expand our knowledge of its many features to streamline and improve our harness design process.